Hello and welcome to a new section in pre-calc, and this is a section 3, and this is about radian measure. And radian measure is another way to for us to measure angles. So that's kind of the basics of it. It's another way to measure angles. Okay, and we're going to use the concept of an arc length. We're going to use arc length to do that, okay? And so what we have is kind of what a radian measure is. Now, a radian measure is, a unit of measure that we use to measure angles, okay? So a radian measure, and let me say this, we use an arc length to measure angles, okay? And it's directly related to the circumference of a circle. So 360 degrees, in a circle helps in using the circumference. We use those to kind of come up with a radian measure. So, by definition, what I want to talk about is how we get a radian measure. So if I have a circle here, okay, and let's say that I have two radiuses, okay, that intersect at this point, and I'm going to call this R sub 1, okay, and this would be R sub 1. Depending on your angle here, which we'll call theta, okay, the arc length, one radian measure is when the arc length of a certain angle is equal to the radius of that circle. Okay, so the central angle is the angle formed by two radii. So here's our central angle theta. Okay, and one radian measure is the arc length created by two radii. Okay, one radian measure is the arc length created by two radii, and the arc length is the same length as the radius. Okay. Now, you could have a number of these, okay? It doesn't always have to just be that same radius. Let's say you have, a radius here created by the same central angle. This would be R sub 2, R sub 2, and the radian for that arc length would also be R sub 2, okay? So that's kind of the idea of what a radian is. It's a way for us to measure an arc length that's the same as the radius, okay? That's by definition like what it is. But what we'll do is we'll use the concept of a circle to go around the circle and to find different types of radian measures. Okay, so another definition for a radian, one radian is the measure of a central angle that intersects an arc length of equal to its radius. So that's what we talked about before. So S is your arc length, okay, and R is your radius, okay? And if you take those and you divide those by each other, it'll give you your angle measure in radians. So this is your angle measure, okay? But what we want to make sure you understand is this is not in degrees, okay? It's in radians, not in degrees. Okay, so that's the idea. Okay, so what we want to do is, let's use the definition of this radian measure. So using this formula that we have for radian measure to calculate the measure of a central angle in a circle having a radius of 12 centimeters and an intercepting arc of 21 centimeters. So let's do this real quick, okay? Let's say you have a circle here, okay, and let's say that this is your radius, R, okay, And let's say that this is your arc length S, okay? And let me make this red here, make that an R, and make this an R. Okay, and then our angle measure in the middle is theta, okay? And what we don't want to do, we don't want to measure that in degrees, we want to measure that in radians. So what we can do to figure out what that is, if we know, let's say that our arc length is 21 centimeters, and that our radius is equal to 12 centimeters, then what we would be able to do is to figure out that angle measure in radians, and that angle measure theta would be equal to 21 divided by 12, okay, which would give us an angle measure in radians of 1.75 radians, okay? And that's an angle measure, okay? This is an angle measure, all right? But it's different because it's really just measuring the central angle here, theta, in a different type of measure than just a degrees. So now let's kind of talk about the comparison between radian measure and degree measure, okay? And so what I like to think about is this. I like to think about this. Let's say I have a radius of 1. And it's kind of the easiest way for us to start off here, radius of 1. Okay, if I wanted to do a full revolution, and that's what they say here, 1 revolution, I know is 360 degrees. 360 degrees is equal to 2 pi radians. Okay, so 1 revolution, I know this, 360 degrees is equivalent, and we're going to kind of use this, go back and forth, to 2 pi radians, okay? So the question is how do you get 2 pi radians out of 360? So you have to think of the arc length of this circle, okay? So what I like to think about is if our radius is 1, well, we can calculate the arc length of a circle by using its circumference. So I know this. I know that circumference is equal to 2 times pi times your radius, okay? So the circumference, if your radius is 1, is just going to be 2 times pi times 1. So your circumference is 2 pi, okay? So your circumference, the distance around your circle, okay, is 2 pi, all right? So if you wanted to talk about, doing 1 revolution around this circle, okay, a revolution of 360 degrees, and the same thing would be, that's in degrees. If you wanted to talk about the actual length that you go, okay, would be 2 pi. Okay, now what I'm going to do is I'm also going to talk about, let's think about something else. Let's say you had, you want to do a revolution of 180 degrees. Okay, so if I did that, let's say I did a revolution of 180 degrees, okay, 180 degrees. Well, what I'm doing here is I'm taking 360 and I'm dividing that by 2, okay? And then if I took 2 pi and divided that by 2, then we get that 180 degrees is the same thing as saying pi radians, okay? And basically, we call that pi, okay? If I cut that part in half and did 90 degrees, okay, then I'd say that 90 degrees, let's do that, an arc length of 90 degrees, okay? I know that this is going to be 90 degrees if I cut that in half, and that's going to be pi over 2 radians. Okay, so 90 degrees is the same thing as saying pi over 2 radians. All right, now let's cut that in half again. All right, so if I did half of that, okay, that would be 45 degrees. So cut this in half, same thing as multiplying by 1/2. Then I would get 45 degrees is the same thing as pi over 4 radians, okay? So, typically, what I was doing before, when you had something like this, like 1.75 radians, this is a thing, okay? But primarily, we're going to use this concept where we use this idea of 2 pi radians is 360 degrees. We're going to use pi in all of these down the line. But let me quickly write in here real quick that this is going to be 45 degrees and that this is pi over 4 radians. Okay. All right, so let's move on. And we have this thing here where we want to where we can convert from radians to degrees. Okay. Now, like I said up here, and I'll revisit this again in future videos. Okay. But I'm just trying to show you the different types of radian measures. The ones that we typically will have and will look at are based off of this concept of 360 degrees is 2 pi. Okay. If you understand this and you know this, you can always go back and regenerate all of the other radian measures and kind of figure that out. I'll show you guys how to do that in the next unit. Okay, so but what I want to do is I want to convert radians to degrees. Okay, and we use this formula, okay, where we multiply the radian measure by 100 degrees over pi radians. Okay, so what I want to do, if I wanted to take this number and convert this into degrees, then I take this number, which is 7 pi over 12, okay, and I'm going to multiply this by 180 over pi. Okay, now what's going to happen here is that your pi's are going to divide out. Okay, so then you end up getting this value here, which is 7 over 12 times 180 over 1. Okay, so if I take 7 times 180, all right, that's going to give me 1,260 divided by 12. If I take that number and divide it by 12, that's going to give me 105. And this is 105 degrees. Okay? So you can take these radian measures, okay, and you can convert them into degrees by using 180 divided by pi. Okay? And that's the idea here. 180 and pi are the same thing. Okay? So that'll help you do that. All right? If we wanted to convert degrees into radians, okay, then I would do the opposite, okay? Take your degree measure, which is 120, and I'm going to do this, 120 degrees divided by 1 times pi over 180 degrees, okay? And really what this is, when you do those two, you're going to get 120 pi over 180, okay? And I just want to simplify 120 over 180. And you can think of this as 12 pi over 18, okay? That's how those kind of divide out. And then 12 over 18, that's going to be, what is that, 2/3? So this is going to be 2 pi over 3, okay? Each of these are divisible by 6, okay? So 12 divided by 6 gives me 2, 18 over 6 gives me 3, okay? And so this is my radian measure, 2 pi over 3 radians, okay? So it's just another way for us to describe what an angle is, but it's an arc length, okay? So that's the idea. All right, so now let's kind of talk about arc length and using arc length, you know, with knowing what, you know, using that formula we had on the other page. Okay, so remember the formula theta in radians is equal to the arc length s divided by the radius r. Okay, and so what I know, you know, we have to use this formula here. Now, one thing that I could do is I could multiply both sides by r and r. And so, you know, you have this original formula here, but if you multiply both sides by r, you end up solving for the arc length s, and you get the formula s is equal to your radius times your angle measure theta, okay? So what we want to do is say how long is the arc intersected by the central angle of pi over 4. So this angle here is pi over 4 with a radius of 20 inches, okay? So what I want to do is this, okay? Find my arc length s. My radius is 20 times my arc length. I'm going to do 20 over 1 times pi over 4, okay? And so then if I divide these out, all right, let's do this. 20 pi divided by 4, Okay, the 20 and the 4 divide out to 5, so we get an arc length of 5 pi. Okay, so that's our arc length. 5 pi is our arc length S. Okay, and that's that. Okay, and that's in inches. Okay, 5 pi inches. All right, and if you wanted to actually like evaluate that, I mean, 5 pi is just 5 times 3.1415926. Okay, and if you multiply those together, and some calculators actually have a pi button, so you can do 5 times pi, and this would give me an arc length of approximately 15.7 inches. Okay, and that's the idea. Okay, so when you see this like 5 pi, I mean, you're taking that number and you're multiplying it by pi. Okay, and you're getting that in an actual number, but it's just easier to write it like this as 5 pi. Okay, all right, so then on the last one, okay, it says applications of arc length. Okay, if a clock minute hand is 8 inches long, how far will the tip of the minute hand travel when it moves from 12 p.m. to 12:15 p.m.? Okay, so let's just draw a picture here. Let's draw a circle, okay, like a clock face, okay, and let's draw the minute hand like this, okay, and this is 8 inches, okay, and we want to know when does, if we go from 12 to then 12:15, okay, so this would be 12:15, this position here, okay, how far will the tip of the minute hand travel? So what's this length here, S? Okay, but the question is, okay, this is also 8 inches, but the other question is what is our angle measure here, theta? Okay, and this is where that previous page came in. This is going to be a 90-degree angle. Okay, now let's think about it. We know 360 degrees is the same thing as 2 pi. Okay, if I divide this in half, okay, I get 180 is equal to pi. Okay, divide that by 2, you get pi. If you divide this again by 2 to get 90 degrees, divide this by 2, that's going to give you that 90 degrees is the same thing as pi over 2 radians. Okay, so that's our angle measure. Theta is equal to pi over 2 radians. Okay, so let's figure out that arc length S if you have a clock that has a minute hand that's 8 inches long. So what I'm going to use is S is equal to R times theta. So your arc length S is equal to your radius, which is 8, times, and I'm going to do 8 over 1 times pi over 2. Okay, and this is going to give you that S is equal to 8 pi over 2. So 8 over 2, that's going to divide out to 4. So your arc length here, S, is going to be 4 times pi inches. And that's it. Okay? So that's what we've got. So that's a radian measure in a nutshell. Okay? And what we'll do when we talk about the unit circle, we will go into a much more detailed thing on how you get all the different radian measures. So thanks a lot. See ya. Bye.